Alright, welcome to part 3, dimensional analysis. The next type of problem that we have to learn how to work with is when our units have exponents, or I should say exponents other than 1. Up until now, we have worked with things like feet to inches, or we've worked with miles per hour to meters per second, and all of these actually have units or exponents to the first power, okay? And remember, if something's raised to the first power, then it's just itself, so we can ignore it. But now we are dealing with units that have exponents other than 1. So it can be squared, it can be cubed, and so on and so forth. Alright, so let's just dive right in. The first thing you're going to do is just like we've done in all the rest of the problems. You've got to put the given over 1. And so we identify that the unit here, or excuse me, that the given here is 16 inches squared. So we're going to put 16 inches squared over 1. Put our little multiply sign and then put our dot. Okay, so right off the bat, you can see if you've got inches squared on top, you're going to have inches squared on bottom. That looks like a 3, not a 2. Let me change that. Okay. And then we need to go ahead and list some conversion factors. Okay, so the only conversion factor that we need is this one that you were told to memorize a while back. 1 inch equals 2.54 centimeters. Now, we can't just plug that in up here in this second bar, and that's because this is just inches, and we have inches squared that we have to deal with. Okay, so what we're going to do then is we're going to go ahead and put our 1 inch in here, and then in parentheses say that we're going to square that. And then on top, we're going to put our 2.54 centimeters, and we have to square that too. Since we squared the one on the bottom, you have to square the one on the top. And then we just do some math individually here. We know that 1 inch times 1 inch equals 1 inch squared. Okay, and then we come up here on top and we say 2.54 centimeters times 2.54 centimeters equals 6.4516 centimeters squared. Okay, so now we could rewrite this problem. We could say 16 inches squared over 1, and then we could say 1 inch squared equals 6.4516 centimeters squared on top. And inches squared cancels inches squared, and we'll be left in units of centimeters squared, which is exactly what we want up here. So we're done. We're ready to multiply across the top and divide across the bottom. And we get 103.2256 centimeters squared. Now, let's do our significant digits. How many significant digits do we have in the number 16 up here? Okay, let's review our rules. Is there a decimal or no decimal? Okay, there's no decimal, which means you start counting on the right-hand side. Find the first non-zero digit, which would be 6, and then count everything over from that. So that's 1, 2. There are 2 significant digits. Now let's look down here at our answer. We have the first significant digit right here because there is a decimal in this number. So that's 1, 2, 3, 4, 5, 6, 7 significant digits. Okay, so we have to cut it off right here at this second significant digit. And we do that by looking at this third one and seeing if it rounds the second one up. It does not. So does that mean that we just make it 10? No, because 10 is not anywhere close to 103. what you do is you drop everything else. Everything else becomes zeros. So our answer then, with the correct number of significant digits, is going to be 100 centimeters squared. Uh-oh, there's no decimal point here, which means if we start counting on the right, find the first non-zero digit, we get 1. So this actually only has one sig fig. Well, if we think we're going to be smart, just go ahead and put a decimal point here. Now there is a decimal point in this number. You start counting from the left, and the first non-zero digit is 1, 1, 2, 3. Now it's got 3 significant digits. So actually the only way to represent 100 with 2 significant digits is to turn it into scientific notation. So we go back up here, find our decimal point, and count over 1, 2. Okay, and then you write the first 2 significant digits. That's a 1 and a 0. So 1.0. Remember, the decimal point always moves behind the first non-zero digit, and the first non-zero digit here is 1. So we've got 1.0 times 10 to the, and then our exponent is how many times we moved the decimal place. And then we have to decide if the exponent's positive or negative. If the original number is greater than 1, then the exponent's going to be positive. If it's less than 1, it's negative. And of course 103 is larger than 1, so we get a positive 2 exponent. And then we just drop our unit down. So we end up with 1.0 times 10 to the second centimeters squared as our answer on this one. Alright, so let's just do one quick review here for dimensional analysis when our units have exponents. You're going to use your standard conversion factors just like you always have, but you're going to have to put those conversion factors in parentheses and then raise them to whatever exponent the problem was talking about. And remember, when you have something in parentheses and you raise it to an exponent, that applies to everything inside the parentheses. So that would include the number and the unit, which is why we did 1 times 1 and inch times inch. Alright, 1 times 1 is 1, and then the unit inch is actually raised to the first exponent, and then this unit inch is raised to the first exponent, and then your algebra property says that whenever you are multiplying something with the same base, then you can add the exponents together. Okay, so that's why you end up with inches squared, because 1 plus 1 is 2. So that's how come we end up with inches squared over here. And then, of course, we did the same thing up here with our 2.54 centimeters. You multiply 2.54 and 2.54 to get your 6.4516. And then centimeters to the first exponent times centimeters to the first exponent equals centimeters to the second exponent. Okay? Okay, so let's go ahead and work this problem here. This one is a complex problem. Alright, it involves units that have exponents on them. It involves our simple one-to-one units where it's not a derived unit. And since we're actually asking about gallons here, gallons is the English unit for volume, we will have to use our volume formula, which is length times width times height. Alright? And that's what gives us our units with exponents on it. The first thing that we're going to do is go ahead and apply that volume formula. You'll notice that you've got 7 feet by 15 feet by 9 feet. Now you can't put all three of those over one and try and run a problem. You could work it individually with each one of them and then add it all together at the end, but that's way too much work. So what we're actually going to do is we're going to find the volume in cubic feet first by multiplying 7 feet times 15 feet times 9 feet. And when you do that, the volume of this swimming pool is going to be 945 feet cubed. Okay? So that's actually going to be our given. Alright? This is going to be the thing that we put over 1. So let's go ahead and do that. 945 feet cubed over 1. Alright, and we're going to put our little dot and another bar. And the thing that we're trying to get to is gallons. Alright, we're trying to get to gallons. So, since we have feet cubed on top, we're going to have feet cubed on bottom. Now remember, when you have these units with exponents, you're going to use your normal conversion factors, which we have down here, and you're going to put them in parentheses and raise it to the exponent that we're trying to go for, which is cubed. So I see that we have 1 foot equals 12 inches down here. So that's the one we're going to use. 1 foot equals 12 inches. And since we have to cube this 1 foot down here, then we're going to have to cube this 12 inches up here. Alright, and keep going. So put another dot, put another bar. We're going to have inches cubed on the bottom. And then we look down here and we see that 1 inch equals 2.54 centimeters. So we're going to be able to say that 1 inch, and we're going to cube that, is equal to 2.54 centimeters, and we'll cube that also. And then we will add another dot and another bar, and we're going to have centimeters cubed on bottom. And notice here that as we went through the problem, we had feet cubed and feet raised to the third power is feet cubed, inches raised to the third power is inches cubed, so that matches. Centimeters raised to the third power is centimeters cubed, so that matches. So we're going to be able to say that 1 centimeter cubed equals 1 milliliter. And remember, that was one that you were supposed to memorize, as well as the 1 inch equals 2.54 centimeters. You're supposed to have both of those memorized by now. So we can cross that one out. And we'll add another dot and another bar. And since we've got milliliters on top, we have to have milliliters on bottom. And I see that 1,000 milliliters is equal to 1 liter. We can cross that one out. We're not to gallons yet, which is what we're after. So we keep going, add another bar. And liters on top means we have to have liters on bottom. And I see down here that 1 liter is equal to 1.06 quarts. Okay. And this is another conversion factor that you are supposed to have memorized. Alright, so we can cross that one out. And we're not to gallons yet, so we're going to add another bar. And with quarts on top, we have to have quarts on bottom. So we'll look down here, the last conversion factor, 4 quarts is equal to 1 gallon. And we'll cross that last one out. Okay, so we ended up in the unit that we were trying to get all along, so that means we're done with the problem. We are ready to multiply on the top and divide along the bottom. Okay, so you're going to take, well actually I think first off what we need to do is go through, and everywhere where we have these parentheses with an exponent, we need to figure out what that number is equal to. So let's see here. 12 times 12 times 12 is going to be 1,728 inches cubed, right? And 2.54 times 2.54 times 2.54 is 16.38706.4. That is a terrible 6 centimeters cubed. And then, of course, down here, 1 times 1 times 1 is 1 foot cubed, and 1 times 1 times 1, 1 inch cubed. Okay, so these, and that's multiply sign between there and there. So really, in your calculator, you would say 9.45 times 1,728 and hit the enter sign or the equals button, and then you would have your whatever that answer is times the 16.387064, and then you can ignore these two ones here and then multiply by 1.06, and you can ignore this one over here. Now it's time to divide along the bottom. So the first non-1 thing is 1,000. So divide by 1,000 and hit enter, and divide by 4 and hit enter. And if you do all of that correctly, then you should come up with 7,090 gallons as your answer. Now, and I guess to be specific, well, it's gallons of water because the problem asked for gallons of water. Now you're saying, well, that's not what the calculator showed me. It didn't show me 7,090. This is with the correct number of significant digits. Again, you're going to look at the given to see how many sig figs you need, and that this number has no decimal point, so we start on the right hand side and find the first non-zero digit. So that would be 5, and then count everything after that, which is 4 and 9. So that's 1, 2, 3 significant digits. So over here, 709, that's our first 3 significant digits, because in the calculator number did have a decimal. The number that came after the 9 was not large enough. I think it was a 1. It's not large enough to round the 9 up, so it becomes a 0, and everything after it becomes a 0. So 7,090 gallons of water is how much that swimming pool can hold. So that problem really kind of encompasses most types of dimensional analysis that we would look at. And this video is running quite long, so I think we'll wrap it up here. Thank you for learning with me today.